Welcome to the next part of the tutorial, and in today's lesson we're gonna, as promised from the previous one, we're gonna use these two characters and populate them to create a crowd of people. Literally a little bit of population walking around of people with the use of PCG. And then you can use that by using PCG you can control the number of people that you wanted him to walk, at the same time control its density. And of course I'll show you how to do step by step. What I'll be doing now is I'm gonna start off creating blueprint first. So that'll be the easiest thing to do. But first things first, before you do anything, make sure on your plugins, make sure you are gonna enable only PCG plugins. So those pretty much what I tend to do, because I need to do this free, but because for this exercise you just need this one and this two, literally those two plugins in. Make sure you do this. With this out of the way, next thing is what we're gonna do is go to content drawer and basically create our first actor blueprint. So we're gonna select actor, let's call it BP crowd, and then double click on this. Once you're inside, what we're gonna do is make sure first is to add spline. So spline will help us to create a specific space within. But because what I can actually do is there are a few tools that are already existing within Unreal, right? And which is very handy because you don't have to create this spline by itself by dragging and multiplying these points, spline, and connect them all together. What you can simply do with its spline selected, right click in the space here, which is you see the little ball there, white one, right click in there, go to a spline generation panel. And what we'll do, it will automatically show this little, as you see, that menu, and you can select the shapes you want to work with. In this case, I'm very interested in using circle. I'm okay with this. Make sure everything looks okay to you, and I think it should be enough for us to work with. Yeah, so I think we are free numbers, that should be enough. And key first key. Let me just check what's happening. Okay, now we just have to reverse that. Okay, so now we'll see what's happening. We just have to create a little circle, but because now it's fine, but what I don't like about this, there's still spline control being sort of starting from that point here. But what we can actually do is just simply remove that. So let's click again, and I think we'll be okay now. Yeah, so now we're okay. We just had to delete the first key point here, and then we are good to go. So now save it. Another thing which you always have to remember is to go and add PCG component. So let's go leave it there. This will be for our graph. Then next thing what I'll do is I'm gonna create a little variable, and I'm gonna call number of people, right? This is where we're gonna dictate and set it to make sure that we have sort of a controller when the viewport where we're gonna able to manipulate the number of people that is going to spawn within that within the space here that is within inside the spline. And obviously one thing for certain which is very important here is to make sure we set the slider range as well as value range here, because the reason why it's very important is because when we start building our spline controller as with the PCG graph, what's going to happen is that when you start hooking up all these variables, when you start from zero, this is where it comes to the very dangerous section where unfortunately but PCG is quite sensitive to these numbers, especially when you set it to zero. Because what happens when you start setting up to zero, that means it's kind of going to infinite loop of spawning all these characters all together. That's where it tends to crash, and your engine may crash, and you're gonna have to restart project from the beginning, and we don't want that. So just so that we know that we're gonna bypass this issue, we're just gonna simply set some few rules, which I'm gonna put them right here. So this is our values, 50 and then 300, and I'm gonna basically start with, let's say 100. Yeah, so at least we know that we're in the safe zone, we don't have to worry about, and at least there's not gonna cause any compilation issue later on. In this case, of course, we have to still do a little thing, which this case we need to make sure it's visible, but otherwise it's not gonna be able to pick it up. Compile it, save it, so that we also maybe have a category, so we know that we're gonna have it available in our menu here. So once I actually go and drag and drop this, we're gonna have, as you can see, we have our blueprint available, and maybe just so that I can also, maybe I can slightly move it in the middle, somewhere around here. Oh, maybe no, just leave it on the edge, so it's easier to move things around with that. So let's just, yep, there you go. Let's expand it a little bit. So then, you know, at least we have something ready with to work with. Also, another thing which I forgot to mention, make sure your spline control is closed, because if you don't close it, then obviously there will be error coming up in your inside PCG graph that the interior is not being we are not that the PCG graph is not able to fill up crowds of people within this space of spline controller, because the loop has not been closed. So that's why we need to make sure it's closed. Compile that, and then we can just start moving things around. Okay, so it looks like the one add point has been added. That's okay. We can always remove it, selecting the press delete key to remove it. All right, so let's leave it as it is. And now, as we see, there will be our also if you select this crowd, then you can see on the details panel there's going to be a let's have a look just to make sure. Oh no, it's okay. So I mean, so now you see when you click on the blueprint actor here, then you can see the people appears there, the variable, which is fine, we need that parameter there. Cool. Next, let's go create our PCG graph. This is the most important aspect of our tutorial. So speaking of which, we go PCG, and then we are going to call it crowd, just like that, but big crowd. And also I'm gonna do just like I can expand that. So yeah, first things first, what we want to do is to make sure we are getting some data, actor data. That is the actor data we are going to use from these two characters we have available here. So in order to make this happen, we have to first derive it somehow from. All right. So in this case, I'm actually going to use my get actor data as a spatial data, which then will be a our initiating point to initialize, but also start to send information what type of data we're dealing with. Which in this case, in other words, we have an actor data. And of course, this all happens in spline. So we're gonna add spline sampler. And basically, as simple as you can imagine, just connect it together with spline, make it straight. Okay, so we're here. So next section is to define how we want to make the spline sampler happening within that space. So every time we have some data feeding into spline sampler, which is in this case our spline here, will be all populating within this inside interior. Because the moment what's gonna happen is gonna only happen on the spline, but we want to make sure it happens within the spline, so we need to set it to interior. On the interior, as we go along, we are going to be going and work with the values, which is the interior sample spacing. But because we have to always keep in mind that when we start to populate objects within that space of interior, we need to make sure this space is unbounded. In other words, otherwise actors won't start to appear, they won't be able to appear, and basically they'll be not appearing at all. So we need to always make sure we tick the box. So that next bit is definitely gonna be working is the number of people. So number of people will dictate based on the interior sample spacing here. So technically, it shouldn't be called number of people. It should be called the distance between people. But because I used it as a basically some formula, like an idea, so I guess would be super cool if you can maybe just call it maybe a distance between people. Let's say, right? And then because the smaller the number is, then the more people will be filled up within the space. Okay, so basically that's what literally means. So for this to make this call be able to work with the variable that's here into our graph, what we need to actually do is basically right click, and let me just make it a little bit bigger. Make right click, look for get property actor, which is get actor property, and use this and name that your variable that you have created. So I'm going to do F2 for rename, copy it, paste it here, and voila, this is our variable. So now, because we can use this to connect it with our interior sample, which is this, which is literally defined here, right? So I can just go all the way down and look for some interior sample spacing. And there we go. This is one out of the way. So this is cool. This is something that we already have something going on. Of course, there's nothing yet ready because we still have to define our transform formations of each spawn points and meshes in this case. But also we want to do is start spawning actors. So first things first, we're going to go right click and go to transfer points. Add this to our graph. So in this case, as the name says, all transform points will basically dictate the transformation of each point and how you want them defined within using these positions of each transform parameters to dictate how it's going to be randomized with rotation, offsets, scaling, and so on. So in this instance, because what we have already, it's a sort of working, sort of like a little nothing else than just working nodes. We can actually use this to debug it, right? So we can, in this case, we can click debug or press D to debug, and then now save it. Of course, nothing's happening because here in the scene, because we still have to come back to our actor plane we've created and use this graph that we already created. So in this case, I call it PCG crowd, and just and there you go. So now as you start seeing the points started to appear, right? That's enough to see, to understand what we're dealing with is that we are actually going the right direction. So we can just turn that off now, or maybe just keep it so that we also still want to see how it will behave. We're gonna rotate it in different directions. So let's say I go -90 at the Z axis and goes here as well 90. And maybe I can change my scaling a little bit. So maybe I go 0.9 and maybe 1.1, like the tallest characters out there. So now you start seeing my cube started to be, they seem to be in the same shape, but that's fine because same scale. The reason why, because we still have to do a bit of this. Yeah, and I think we should be okay now. Yeah, so if we're gonna start moving, so it starts having different sizes. Yeah, they started to kind of appear in different size, which is enough to have it to work with. So that's good. So we can now carry on with the next section. And in this case, what I'll do, I'm gonna go very quickly, right click and look for spawn actor. So it's spawn actor, because we don't have anything yet, so that's why it's not gonna do anything. So in this case, we're gonna have to make sure we actually start spawning a few actors. And to do that, we have to go merge PCG only. This is the option we have to choose. And the actor we wanna look for is our people that we've created. So in this case, I call it, so it's a female. So let's use female for, it's a BP underscore F person. Okay, so there you go. So voila, you see now we started to having some formation of these characters on the scene. And now you can if you want to expand a little bit more, and also let's go back to our blueprint that we have. And you see all these people here as there's female person being generated, and it caches out here on top of the outliner. And also what's so cool about it, you can actually individually modify that and do things whatever you want to do with that. But that's another story. For this now, we want to do is to select the crowd and also distance them. So if you go further away, that means that the further away they go from each other. If you want to make them closer, you make this. If you want them very close, a little bit too much, but hey, it's a cool thing to experiment on. So let's stick to maybe 150, okay, for now. Let's make it a little bit bigger, and we can just make it slightly bigger. Let's create a new point here, point there, and now see there's a whole army of them. Cool, right? So maybe because it's too much, so I'm gonna basically, okay, let me remove these characters here because they're gonna be on the way. Let me get rid of them. There you go. So let's just focus on them. So now I am gonna go and on the crowd, I'm gonna go to 100. The way it works is using Unreal units. In other words, I think it's set to centimeters, which means if you go close enough and you'll see how far they are from each other, you can tell they're kind of two each box. So that means there are 2 meters. Tile here represents 1 meter by 1 meter. So that means this is another 1 meter by 1 meter. So if you add them together, it's going to be 2 meters apart from each other. So basically what that means, right? There are 2 meters from each other, 100 centimeters from each other. So if you go 100 centimeters, they go 1 meter from each other. Because it's in centimeters, 100 centimeters. So that means there are 100 centimeters away. So let's set it to 200 centimeters away from each other. Okay, cool. Another thing is to see how this all works. So now for this, let's go give it a test. Also make sure you have enough mesh bound volume, like I showed you in the previous example. I set up to make it big. Hit play, and then you start seeing characters moving around. It's very cool, right? So what's so cool that they are kind of working independently for each other. Of course, they're gonna bump into each other. That's absolutely fine, because you need to also increase the number of it. But this is just for the test to show you what you actually can do with the PCG blueprint. It's also very good if you have some obstacles around. So let's say you put some cubes and blocks and so on. So maybe it would be very cool to diversify a little bit, and let's put male here guy as well. To do this is actually you can copy it and paste it as well like this, or maybe you can also continue flow. But in this case, we're gonna use our male. They're gonna kind of look like they're on top of each other, but that's fine, because if you compile it and let's say play it, they're gonna separate from each other. As you can see, they just literally moved away from each other. So that's another way to work with your spawning different actors. Also, what would be super cool if we can make some obstacles. And to do obstacles, it would be super cool if we can actually make this define it by actually having some objects in front of them. So some of the PCG gets removed. And we can actually do this using difference node. So it's not too difficult to set this up, but let's do this together. So I am gonna go and actually go and create difference node, right? Add it to the list. And make sure first, because this has to be fed as a source. So this our source is our here spline, which we are working on to create a crowd. So we need to hook this with this. And also let's bring those guys here. So this will be our out characters, which means these are going to be our characters, which then will spawn as an output value. But here, because we're thinking to see if we can fit other objects, which will then not interact, but kind of make the difference between the objects that are, in this case, crowd being spawned, and also the objects there which will be on the scene. And you actually can sort of like differentiate them. In other words, you can kind of spawn the actors within the PCG area, but also you can define the positions of new added, let's say, items, meshes, actors, which has a tag on it. And then based on this information, you can feed this into the difference node and make the difference between them. So to demonstrate a bit more, let's try this with one example. And I think what I'm gonna do, I'm gonna actually add something like a cube, okay? In the middle, just make it slightly bigger. Somewhere there, of course, it overlaps with others, but that's fine because that's where the difference node comes in to eliminate that issue. And also, before we do anything, we need to define what this cube is. So to do this, we're gonna have to go to the tag panel and make sure always go actors, because we're dealing with actors. We know that the components are two different things. So I'm gonna add it. I'm gonna call, I guess, obstacle, right? Something like that. So at least we know what's the name. Let's copy this name. And let's, sorry, what's happened? Obstacle, yeah. So, and then I'm gonna go back here and I'm gonna do what we already have done here, but we're actually gonna add another get actor. Let's go and get actor data, and we're gonna define it by all word actors, which means they will go into a tag mode. That's where we're gonna use this tag, which we just created for the cube, and use it as an obstacle. So now if you put this in, technically it should be working. So if I bring that in, so now you start seeing my cartridge being removed when it start overlapping. But also what you can do is actually can literally make it slightly bigger. All right, there you go. But what you can actually do is also define its bounds within the space that it's being distributed, as well as where the cartridge is being populated. And you can actually do this by using bounds modifier. So let's go back to our graph and start adding this nodes too as well. So let's call it bounds modifier. And then I am gonna do is that deselect that and select this, connect it all together. And then I'm gonna go to my bounds modifier, and I'm gonna go maybe play with some settings here. All right, so I'm gonna go maybe 1.5 here as well, 0.5. So I'm gonna do this for every single individual. So that goes on all axes. I'm gonna also use stiffness so that it's a lot easier to play with the settings. So now you see my spacing has moved kind of got modified, but you see that spacing in between got much larger, right? Because we start adding those values. That's what represents these values, these vector positions, to give you more scale space in between that cube that is here and those spawn actors that comes within that parameter. We can actually make it bigger if we wanted to. As you can see, they start to disappear a bit more. The finger even fire there, and you see that disappear more. But let's try and keep it as low as we can. So let's try 1, 1, 1, and 1. Okay, and then we can actually use steepness as well. Let's try 2. So they're gonna work on all axes. So if you go further up, it still should work. If you go this direction, it should work this direction also. So it perfectly works on all axes. So that's good. So in this case, you had a chance to create like a cool effect of actors being spawned and that certain element of the graph as it within the outline spline control that is literally within the actual blueprint. But also you had the opportunity to add some few nodes to remove some of the some of the spawning actors using the obstacle actor data, which we have assigned it to our cube here. So with this completed, what we can actually do, let's try see if we can just add some more cubes here. Let's have a look. Cube, there you go. So we're not gonna tag them, we're just gonna basically allocate them. So every time we move them around, just so at least we know that there are a few blocks. So every time the actors start to move around, they're not gonna bump to each other characters. They're gonna just go obstacle within the navigation mesh. So if you click P to see what's happening to our navigation mesh, you see all of these are being placed as like walls. So now if I hit play, then you start seeing that characters start to move, wander on their own way. So so it's very cool to work with. And then so now you start seeing the potential its potentials to maybe work with your projects with just simply setting up that kind of work. And as you can see, my frame rate doesn't go too low because I can see I move very fast with this, and then it doesn't really take too much of a performance because we are using instant static meshes, just like explained in the previous video. So it kind of gives you a clue how powerful it is if you mix up these optimization skill sets and basically using what we have existing PCG now. Yeah, because sometimes you might end up having this. It's just because they need to be more spaced out, literally, the characters. And possibly maybe one character is already standing, and it's really interesting to see how it all works. But anyway, it gives you a little bit of the interesting idea what you can actually do with this in the first place. So because the characters seems to be very close to each other, yeah, anyway, so that's it for today. I hope you guys enjoyed that, be a little series of tutorials, so you guys learn how you can actually create your own like animations using my tool and my methods on this, and also you are also know how to set this in PCG. Thank you guys, and see you guys next time.